All right, let's do the volume of a cone. Okay. Now that we've established the volume of a pyramid, this will be pretty straightforward. The volume of a cone is actually going to be the same formula. All right, it is going to be the area of the base times the height divided by 3. We could do the same experiment with these, with the cylinder and a cone of equal height and equal base. It does take 3 of these full of water to fill that up. So your formula is the same. We just have to remember to divide by 3. So if you're going to write that up here, formula, area of the base times the height divided by 3. If we wanted to get more specific on this formula, all of the shapes of the base are going to be circles. So we can get more specific on this and say, well, that big B right here is going to be pi r squared. And then I'm still going to multiply by the height and divide it by 3. So if you wanted to remember it that way, you can. But it's really easy to use. So here we go. Volume pi times 6 squared times the height of 8 divided by 3. That's really it. You're done. Type that in your calculator and you'll get an answer. I thought that was pretty straightforward. I didn't put the answers on there. You are going to have to be aware, though, like number 3 right here, to use the actual height. So again, 25 is the slant height. This 7 goes over here. So I'm going to have to do 7 squared plus 8 squared equals 25 squared. If you do this in your calculator, you're going to figure out, let's see, I'm going to end up subtracting 25 squared minus 7 squared. The square root of that is 24. So the height is exactly 24, which is nice. Again, I want you to show me this work. You don't have to show me all the steps. I know we should be getting pretty good where we can see what's going to happen in our calculator and do that. Just show me the original equation there. Okay, so again, to do volume, now that I know this, I'm going to do pi times 7 squared times a height of 24 divided by 3. And that'll do it. All right. Let's do another one down here. Here's one that has a cone, a cylinder with a cone-shaped hole. So, for example, if I had this kind of poking part of the way in there, let's pretend this was full of water. If I push that in there, that's going to take away some of the water. It would run over. All right. So that's what's happening. How much volume does this have with that cone-shaped hole? Well, this is a little bit more of a thought idea. And hopefully you're going to see here that the volume we need would be the cylinder minus the cone. Hopefully you see that that's a takeaway or a subtraction idea. All right, so we've got to think here about how to find the volume of a cylinder. Area of the base times the height, but do not divide by 3. So this one is going to be pi times 4 squared. There's a radius. That's area of the base times the height of the cylinder, which is 6. Do not divide by 3 because it's a cylinder. And I'm going to subtract the volume of a cone. Well, that one's going to be the area of the base, which is still pi times 4 squared, because this 4 would have to be the same, top and bottom. Pi times 4 squared times the height of the cone, which would be 3, not 5. The height of the cone would be 3. And since it's a cone, we have to divide this by 3. So that ought to be your strategy there. There's my work. I wrote out my plan. I decided what formulas I needed. And I plugged in all the numbers. You can type that in your calculator. There are some application problems over here that deal with a cone. They're not that difficult. You just need to read, draw a picture. Cones are easy to draw. This one was a little bit interesting. It compares things. So if you had a cone, I'll just draw it like this, with a radius of 3 and a height of 10. All right, what effect does doubling the radius have on the volume? Okay, so that means I would have another one where this radius becomes 6. If I doubled the radius, it says doubling the radius, that becomes 6. But my height was still the same. My height was still 10. What effect does that have on there? You would think if I double that dimension right there, it's going to double the volume. But let's look. So if you do this volume, pi times r squared times height divided by 3. And I do the same thing over here, pi times r squared times height divided by 3. And I get some numbers to compare. All right, so let's see, this right here would be, I'm going to leave it in terms of pi. That would be 30 pi. I can do that in my head. And this one over here would be 120 pi when you type all that out without messing with typing pi in there. That's 36 times 10 divided by 3. That would be 120. Okay, so anyway, look at the difference. That's 30 pi, and this one you would have thought was going to jump up to double that, would be 60 pi. It didn't. It was 4 times larger. So that's a little conversation that we're going to have when we start doubling or changing one of the dimensions. What does it do to the overall volume? What does it do to an overall surface area? That's something that we're going to talk about here in a few days. All right. This is one, again, a paper cup. Hopefully you can be able to see a paper cup. You've gone to a water fountain before. It's the shape of a cone, 11 centimeters deep. That sounds like height to me, 11 centimeters right through here. And then the radius is 4. How many cups can you fill from a 1 liter container? So I need to find the volume of this one, which would be in cubic centimeters. And then you're going to have to figure out how many of these cups can I get out of a 1 liter container. I think you can do that. Volume of a cone is not difficult. Once we've done the volume of a pyramid, we pretty much did the volume of a cone. We just didn't focus on that shape. Okay, so this is even a little bit more specific, a little bit easier because the shape of the base is always going to be a circle. So this is actually a little easier than the pyramids because the pyramids, the shape of the base could change on us a little. So anyway, pretty short assignment. You ought to be able to do this.